Hello everyone, welcome to the French Math Tailor channel. My name is Antonin. I've been a private math tutor the last 12 years. I also teach econometrics at LSE in London. Most of my students come from all around the world and try to get in Oxford, Cambridge, Imperial in the UK, or in Ivy League schools in the US. And so my job has been partly to train them for the typical tests that you have to take in order to get in those schools. And some of those tests will be the math admission test for Oxford, Imperial, Warwick, whenever you want to do engineering or science. Some other tests would be the TMUA or the STEP for Cambridge. And that's one example here. That's one question I found from, I think, the STEP Cambridge test 1997. So a very old question. I think that those questions are usually very interesting. So please send me any challenge you have in the comment, or you can also contact me by email if you have some interesting math question from all over the world. Honestly, it could be like a American question, Chinese question, whatever you want. I'm happy to cover them. I'm gonna try to publish on this channel twice a week, given that I already have a French language channel going on. And yeah, I'll try to do the best to solve everything you guys send to me. Let's get into this question. The STEP at Cambridge, especially the very old questions like this, can be tedious. It can be quite long. The questions are not that easy, and it's hard to do them like really fast. So it's not an MCQ question, it's more like demonstrations you have to do. And so let's try to see what the question already triggers in us. So we see that we have an f function with some parameter a, and we are supposed to show that if a is over some value, the 9/8, then the derivative will be positive. So the function will become basically increasing for some value. So the idea is, okay, we have an increasing function ax, well, given that a is positive, we have this thing that might be decreasing or whatever, and so at some point when a is big enough, like this wins in terms of like the function being increasing, and this cannot take it down too much. Okay, that's the intuition. So the calculation might be weird, so we might have to go through a lot of calculations and check why this is like the key threshold value. So first thing we should do in terms of like little trick you could do is simplify this rational fraction. So I see that x to the power of 3 is a higher polynomial power than what's below the fraction bar. So the first thing I do is do some algebraic manipulations to just simplify this a bit. So I have x to the cube over 1 plus x squared. I'm gonna just make 1 plus x squared appear over there. So what you do is, okay, x cubed is equal to x times x2 plus 1. And so when you do this, you have x cubed plus x, well, minus x over 1 plus x2. So I just like force the the apparition, if you want, like you make it appear here. You make this thing pop out of nowhere if you want, but that's very convenient. So you force it like this. You just say, okay, this is a cube. I just want to write this thing. So the plus 1, we just do a plus 1 and minus 1 here to compensate. And what this gives us is actually a x minus x over 1 plus x squared, which is a way simpler function. So I have in the end f of x equals, so definition and the domain for f is of course the whole set of real numbers, because this thing is always bigger than 1 actually, therefore bigger than 0. So just to be sure, you have like a domain that just ranges through all the values. There's no issue there. So then I have f of x is a plus 1x minus x over 1 plus x squared. It's a first step. It's quick to do if you know how to do your algebraic manipulation, but it will simplify the calculations for later, so it's a good investment. So let's do now the differentiation. We can say that f is a differentiable function. There's no issue. This is a degree 1 polynomial. This is just a fraction of functions that are differentiable, so that's easy enough. So we can do f prime of x equals a plus 1, that's no issue, minus, and this one we try to be safe, so we do this differentiated, so 1 times 1 plus x2 minus x times the differentiation of 1 plus x squared, which is 2x over the function here squared. Okay, so once I have that, I can just move forward with the calculation. I have 1 plus x squared minus 2x squared. Okay, that's 1 minus x squared over 1 plus x squared squared. And the whole question now is to try to understand why we have a specific value a for which this thing is positive. So I think there will be different ways to go through this. So I will keep the channel always kind of natural. I don't really prepare the questions in advance so much. I have done these questions in the past, but when I'm doing them with you, I'm trying to do them like as I would do them discovering them. So like this, you can see me also struggle. I think there's like pedagogical value in this. So you see me struggle and you see me also like try to find my way through the questions. So sometimes maybe 2 minutes of the video will be me struggling, and then you'll see when hopefully I get it right. Supposedly that's my job, so I should do it quickly. And so let's check here what's the condition for f prime being positive, and we just find the necessary conditions if you want. And we do this if and only if a plus 1 is bigger than 1 minus x squared over 1 plus x squared squared. Okay, that's fine. And so what I see here is the first thing I can check here is that this whole function here is actually a function of x squared. And so when I see this, I'd like to check, maybe study if this function is bounded. Like, would this function always be smaller than this value? So I guess this value would be like 9 over 8 plus 1. Like, I have a tendency to be like, when I see this, to like, study this function maybe and see if I can quickly check that it's always bounded by some constant value. And if that's the case, then I'm happy because this will be true. So since x squared is just a positive value, I'd rather maybe write down a new function and say, okay, let's have, big X equals x squared, and just play with g of x, a new function, which is 1 minus x over 1 plus x squared. And if I do this, I know that x is always positive, so I won't bother with any value of x that's not above 0. And then I can check this function maybe. And it seems that if I do this, my life might get easier. So I want to do some algebraic manipulation as I was doing just before, just to simplify this again. So it seems that I could make a 1 plus x appear on top of the fraction here. So I would do, this is minus, and I would do 1 plus x, and here, if I do minus, I'm assuming here I would get x minus 1. So I have x plus 1 minus 2 to just compensate both. So if I do this, I have 1 plus x minus 2. You can triple check me. That's x minus 1 with the minus sign 1 minus x. Why am I doing all of this? It's a simple algebraic manipulation just to get minus 1. I put the minus in the front. 1 because this divides here over 1 plus x minus 2 over 1 plus x squared. I mean, you can discuss in the comments, maybe that doesn't make the study and the differentiation that I'm gonna go through now easier, but I think it does. So let's check with this. So that's 2 over 1 plus x squared minus 1 over 1 plus x. I'm happy to discuss that. Maybe it's kind of time consuming, but I think it can be done pretty quickly. So let's study if this function is bounded by some constant value. That would be ideal. And hopefully I'm hoping that g will be doing something like this, maybe with a value here, and we can check what happens from there. So let's now study g, and so we have to differentiate it. So g prime of x equals, okay, so 1 plus x to the power minus 2, so that's basically 2 times, so minus 2 over 1 plus x power 3 minus, so plus 1 over 1 plus x squared. Okay, I can just factorize everything. So I will do 1 over, since x is positive, I have no issue with the power 3 here. All of this is positive over, so that's 1 plus x for this one minus 4, oops, sorry, minus 4 from this term here. And so that's what I get, which is kind of interesting. That's 1 over 1 plus x to the power of 3 times x minus 3. And so now I can like have a little summary table explaining like, okay, have this here, x starts at 0, goes to infinity, g prime of x is positive when x is bigger than 3, so I have 0 here, minus, plus. I like to do those summary tables. And so g is like this, decreasing and then increasing. So here I'm kind of in trouble. Why am I in trouble? Let's check what happens here. So I feel like I'm in trouble because maybe the values here will be wrong. Like I feel like maybe they are infinite or something, and so I won't have what I want. I wanted to check that this thing was bounded, but let's check. So what's happening to g, the function g, when x is 0? So when x is 0, well, basically g is 1. So I have g is 1 here, and when g hits infinity, when x hits infinity, what happens? So I have minus something here over, so I have some 1 minus x over some x squared. Well, that's totally dominating what's above the fraction bar. So this is going to 0, and I would say 0 lower value, so 0 minus. So I have something here which is 0 minus, so I can assume that g of 3 is negative. We can check this quickly. It's minus 2 over 1 plus 3, so that's 1 plus 3, 4 squared, so minus 1 over 8. And that seems interesting. Why? Because I have a minus 1 over 8 here, and normally I wanted to show that something around the 9/8 here. So I'm starting to wonder if I did not make a sign mistake, maybe. Let me check that. Maybe I have something wrong here. 1 over 1 this. Yeah. Maybe not. So I'm not sure what happened here. 1 minus x over 1 plus x. That seems fair enough. That seems good. Minus 1 plus x minus... Yeah, that seems okay. I'm having doubts now because of this thing, and I can say that g is always bigger than 1 over... Oh, yeah, but I think that's good. Okay, now I got it. So everything is right. You understand, you will see why I was not sure. So let's say now, okay, I have proven, in my mind, I thought I would need to prove that g was always smaller than 9 over 8 or something, but let's check properly what I have found here. I have this thing here that I just duplicate. I have this here, and I have proven that this equals g of x squared if you want, and I know that this is bigger than minus 1/8. Is this helping? I'm not sure. I'm not sure what I did here. If I have this thing here, yeah, do I care about this? A plus 1, will it always be bigger than g? Maybe this 1/8 I don't really care about. The thing I should care about is the fact that g is maximum value is 1, I guess. But then a has to be positive. So something is missing here. I might have might have done a mistake somewhere. So let me go, you know what? I just go through with it. So x cubed, okay. There was a minus here that I might have forgotten. Yes, that's the minus. I did a mistake here. I did like plus here. So it was a minus 1x. Okay, let's start again. Minus 1x plus x over 1 plus x squared. Oh, that must have been frustrating for the people that did see my mistake here, but it's fine. Let's just correct it. You know what? You're doing this at the exam. The important thing is to have this like thing in your brain where you know how to handle the situation. So let's do this. Fortunately, this was clean enough. So I just have to do plus here, and I think I'm good, basically, because I just have a minus 1 bigger than x squared minus 1. like this. And this is really perfect. I think now I have it, because this is minus g of x equals minus g of x squared. And so I know that the maximum value of minus g is 1 over 8. And I know this maximum value, so minus g would be like this, you know, up, with 1/8. I guess this doesn't change, would be minus 1 here and 0 plus here. So I have something like this now, and I want to make sure, like, I want this to be true. In order for this to be true, I need a minus 1 to be bigger than than 1/8. So that was my mistake. So if you want, if I do minus g, and I just do this, this is what I have. Minus g looks like this. And that with condition, like, if do I have the here, like, something that's true, like I have a minus 1. Let's say if a is bigger than 9/8, a minus 1 is bigger than 1/8, always bigger or equal to minus g of x squared. So I have my condition and it's proven. Okay, so that was a good one. Sorry for the maybe the sloppiness of my mistake here. I hope that was not too infuriating, but hopefully you see the pedagogical strength in this, which is, well, sometimes you make a mistake, you have to go back. I was trying to make it work. I was trying to wrap my head around it. And then in the end, you just check from the start slowly and say, oh, okay, that's where I did a mistake. And then I come back and everything works out. So the solution here was to do kind of a double differentiation, but you don't want to do like a double differentiation for f straight away. I would consider just studying this one, a little change of variables, simplifies also all the expressions. And then when I do it carefully with no mistakes, well, actually it was not that many mistakes in the end. It's just like a minus sign. Then you understand what you're doing. You're like, okay, if I want this to be true all the time, I need this quantity to be higher than the biggest value taken here, which is 1 over 8. And so, yeah, the condition given in the question is true. And so that's shown. So for all x, we have shown this thing. I hope this has been entertaining and interesting for you, and I see you in the next video.